Hello everyone. In this video, I will demonstrate how to solve line balancing problem. Basically, you have been given an assembly line and you have to perform certain number of tasks, and you need to make sure that you perform those tasks in the most efficient manner, in the sense that you do not want uh, any idle time, which means that you want to minimize the idle time. If any workstation in an assembly line is staying idle, that means you're not getting as much efficiency from the assembly line. So this in this video we will do one problem that will address the line balancing problem. So here you have been given a set number of tasks A through G, and you have to assign these tasks to different workstation in such a way that you will maximize the efficiency and minimize the idle time. Okay, so this is the data given. So you have given task A through G, you have given their durations, and you have given their relationship with other tasks. Okay, so we'll go through that one as well. You have also given this information that operation needs to achieve an output of 240 units per 8-hour a day. So we want to we want to make sure that we produce at least 240 units in a day, and a day has 8 hours. Okay, so this will establish our cycle time. Okay, so you will be given a very similar problem in the exam, so you should be able to do it using Excel. So these are all the things you need to do. I have striked out E, not needed as such. So we'll do A, B, C, D, and F. So first we have to draw the precedence diagram, then we have to calculate the calculated cycle time, then we have to determine the minimum number of workstations needed, which is n minimum, and then we have to assign tasks to the workstations, and then we have to compute person idle time and person efficiency for the line. So let's get started. When you're addressing a line balancing problem, you have to follow certain rules. So these are the three rules here. Rule number one is assign that task first which has greatest number of followers, okay, or following task. Okay, and in case of a task, so if you have more than one task that have similar number of following tasks, then you will assign that task first which has the longest processing time needs. Okay, so we'll go through it again in the problem. Okay, and in case you still have a tie, then you break the tie randomly. Okay, so there is a slight modification here, I would say. Okay, if you cannot fit in the selected task, try to assign the other task. So in a way, if you cannot fit in the task that needs longest processing time, then probably you will go to the next one that you can fit it in and move on. Okay, so let's get started. Let's draw the precedence diagram here. So, and this is what you need to keep in mind. Okay, when you're drawing the diagram and everything, you have limited time, so you need to maximize the utilization of your time. So this is how I would do it. So I would say insert, let's say here, insert, and I want to insert a shape circle for my task here. Okay, and double click on it and type in A here. Okay, so that's my task. I guess I don't need that big here. Okay, so I need a task and I need a text box to put in the time. So I would go here. Let's say I'm going to put a text box here. Okay, and I will say, let's say task A is taking 0.2 minutes. Okay, so these are the two things we need, right? So here is what we're gonna do. So I will select both of them. So make sure you select the top one first, okay? Otherwise it will be a problem. So you select the top one and the bottom one and Control C, and we need 1, 2, 3, 4, 5, 6, 7. So you have 1, 2, 3, 4, 5, 6, 7. Okay, and then we'll start rearranging them as we need. So let's move this one here. Then again, select the top one first and the bottom one then. Okay, put it here. Select the top one first and bottom one then. Rearrange it right now, so we will make sure they follow the proper directions and everything. Okay, top one and bottom one, I'm going to put it here. Top, top one and bottom one, I will put it here. Okay. Okay, I guess this should do. So here, let's do it. So dash means A is in starting activity. It doesn't have any predecessor. Okay, immediate predecessor. Okay, so we'll start with the A, and it takes 2.2 minutes. Okay, and then B follows A. So this will be my B here. It follows A, right? And it takes 0.4 minutes, right? I'll delete, put it 0.4. As simple as that, right? And then we'll connect this with an arrow. Let's complete this in a sequence. So C follows B, and C takes 0.2 as well. So this is my C, and it takes 0.2 minutes, okay? And D does not follow anyone, so it's a starting activity. So this will be here because there are no activities before D, okay? So, and it takes 0.4 minutes. E takes 1.2 minutes and follows D. So this will be my E here, and it takes 1.2 minutes. Okay. Now F follows C. So this is my F here. It follows C's, and it takes 1.2 minutes as well. Okay, the last one is the G. So this is my G, and it takes 1 minute. Okay, so right now let's go ahead and connect using the line. Okay, so I will use an arrow. So let's try to connect this one. All right, and then you can always rearrange this one and make it look nicer, but you will have constraint of the time in the exam, so need to make sure you don't waste a lot of time drawing this diagram. Okay, as far as you're getting it getting the basic structure right, I don't care about how pretty it is looking. Okay, so this is your diagram. Okay, so probably we might make some space here. I will need it. Okay, okay, so this doesn't look like connected. Okay, so this is our diagram here. I'm gonna make some space here because I will need it down the line. So all this thing will take some time, and you will only have 1 hour to do it in exam. So make sure you practice before the exam. Okay, so this is my diagram. So I have this precedence diagram. So it tells me all the tasks and their interrelationship. So like I cannot start task B unless and until I'm done with task A. Likewise, I cannot start F unless and until I'm done with C. Likewise, I cannot start with G unless and until I'm done with activity F and E. Okay, so these both needs to be done before I can start G, and henceforth. Okay, so second one is calculate the cycle time. Now cycle time, what is the cycle time, right? Cycle time establishes the rate of output. So it basically tells me that how many units we can produce in a given time. Okay, so cycle time could be, I mean, it should be the reverse. How much time it takes to produce 1 unit, that's my cycle time. Okay, so is it taking 2 minutes to produce 1 unit, or is it taking 3 minutes? It could be minutes, it could be hours, depending on the situation. Okay, or it could be seconds. Okay, so cycle time here is given by, this is the calculated cycle time, sort of desired cycle time, and it depends on the output, desired output in a day, and the hours available in a day. Okay, now you have to keep in mind that this table is given in minutes. Okay, and you have 8 hours, so basically you have to make sure everything is in minutes. Okay, so you have to convert that 8 hours to minutes, and this is the formula we are going to use. Operating time per day, which is 8 hours times 60 minutes, divided by output per day, which is 240. So let's do that. So it should be equal to, operating time is 8 times 60, right? It's better to put it in parentheses, divided by output is 240, I guess. Yes, 240. Okay, so make sure you provide opening parentheses here as well. So that tells me, it's in minutes. Okay, so these units are very important. So calculated cycle time is 2 minutes per unit. That means to produce 1 unit, it will take 2 minutes. Okay, so this is establishing the rate of output. Once we have the calculated cycle time, what we can do is we can find out how many workstations we're going to need, just a minimum number of workstation. So in actual assignment, it could take more, but how would you calculate the n minimum? So minimum number of workstation will be given by total task time divided by calculated cycle time. Okay, and this will be equals to, let's sum it up, sum of my task time, which are all this task here. Okay, close parenthesis. Okay, and then we'll divide it by calculated cycle time, which is 2 minutes. So that tells me that we are going to need 2.3 workstation at the minimum, and workstation cannot be in fractions. WS stands for workstation. It cannot be in fractions, so we have to round it up to the next higher number. So we are going to use 3 workstations here. Okay, the reason I'm putting like this in the cells, because I can use that in the formulas down the line. If you just do it here, if you just put it here, 3 workstation like this, then you cannot use this 3 number in the formula. So that's why I'm putting it like that. Okay, so we are done with C as well. Now the main task is how to assign this task to the workstation. So we calculated that we approximately going to need 3 workstation at minimum, could be more, we don't know yet. And we know the cycle time each workstation is going to take. So each workstation should not take more than 2 minutes. Okay, that's the cycle time. Okay, and you have been given the task time. So let's get started. So let's say this is the table we're going to produce here. So I will try to minimize it so we can have this diagram with us. Okay, so I want to see all this in one place. So workstation number 1, to start with, every workstation will have the same time, which is the calculated cycle time. Okay, now what tasks are eligible? What tasks are eligible to be assigned to workstation number 1? Well, all the tasks that does not have any starting or preceding activities, they are eligible. So we can see that A and D does not have any preceding task, so they are eligible. So I will say A and D. Okay, now out of these 2 tasks, which would you assign first? And that's where those rules come into the picture. So what you need to do is, rule number 1 is count the number of followers for each task. For A, you have 1, 2, 3, 4 tasks following. Okay, for D, you only have 2 tasks following. So the rule says that assign that task which has more number of followers. So we are going to assign A here. Okay, how much time is remaining? Well, A takes 0.2 minutes and you have 2 minutes, so time remaining is 1.8 minute. Okay, uh, and idle time, we don't know yet. This will be at the when you're done assigning all the tasks to a workstation, then we'll fill up these last 2 columns. So 1.8 minutes are remaining, so I will put in 1.8 here. Okay, and then I need to go here and do the next task assignment. So A is already assigned, so that means B is eligible as well to be assigned, and D is already eligible because it does not have any preceding task. So here eligible tasks are B, comma D. Which task I'm going to assign? Well, let's do rule number 1 first. So B has 3 followers and D has only 2. So rule number 1 says that whichever has more number of followers, go with that one. So we'll assign B here, okay? And B takes 0.4 minutes. So you subtract 0.4 minutes from 1.8 minutes. So the time remaining is 1.4 minutes, okay? Now, so 1.4 minutes, we are going to bring it here. So next eligible task are we already assigned A and B. So C is eligible because B, A and B are already assigned, and D is already eligible, okay? So we are going to say C, comma D. Let's count the number of followers. Now C has 2 followers and D also have 2 followers. So there is a tie. So in case of a tie, the next rule says that try to assign that task which has higher processing time needs. So D takes 0.4 minutes, which is more than 0.2 minutes. So we are going to assign D here. Okay. So we're going to assign D here. Now, sometimes it could happen that you cannot fit in 0.4 minutes because you don't have enough time left. And let's say you only have here, instead of 1.4 minutes, you only have 0.3 minutes left, okay? So in that case, you cannot assign D, right? So in that case, if you cannot assign D, you would go back and assign C, okay? Just telling you, because there could be questions like that in the exam, okay? You need to be aware of these rules, okay? So we are going to assign D is going to take 0.4 minutes, so time remaining will be 1 minute. Okay, so we'll bring 1 minute over here. So next assigned tasks are obviously C was eligible and D already assigned, so E is also eligible. So it's going to be C and E. Okay, so C has more number of followers. Okay, and E only has 1 follower, so C has 2. So we're going to assign C here. Okay, C takes 0.2 minutes, so time remaining is 0.8 minutes. Now 0.8 minutes is remaining. You need to constantly keep looking at the diagram, okay? So next eligible activities are E and F, and they both need 1.2 minutes. So we don't have enough time left here. That means we cannot assign any more tasks to this workstation, and my idle time is going to be from this workstation 0.8 minutes. That's how much is remaining, right? And how much total time is being consumed by this workstation? Well, if you subtract 0.8 from 2, you will get 1.2 minutes. Okay, so this is the total time that's being consumed by this workstation number 1, and the idle time is 0.8 minutes. Okay, so that's my task assignments to workstation number 1. So once we are done with 1, let's move on to 2 here. Again, every workstation will have 2 minutes to start with because that's our calculated cycle time. And let's see what tasks are eligible now. So we have assigned A, B, C, and D. So eligible tasks are F and E. So we are going to say F and E here. Which tasks you are going to assign? So let's go by the rule number 1. Both of them have the same number of following tasks. So both of them have 1 task following. So they have same number of tasks. So in case of a tie, we need to assign that task which has higher processing time needs, right? But they both have the same processing time need as well, right? So that we'll go to the rule number 3. In case you still have a tie, break them randomly. So at this point of time, it doesn't matter whether you assign F or E because we have to break the tie randomly. Okay, so let's say I'm going to assign E here, and E is going to take 1.2 minutes, and I know that the next eligible task is F, right? And it's going to take 1.2 minutes as well. So time remaining here is 0.8 minutes only, okay? So we cannot fit any more task for this workstation because time remaining is only 0.8 minutes. and the next task that you are going to assign will need 1.2 minutes. So the time remaining, time consumed is going to be again 0.2 minutes, because subtract 0.8 from 2 minutes, you get 1.2 minutes. So this is how much time is being consumed by this workstation. Move on to workstation number 3. Again, we will have 2 minutes to start with. And what are the tasks eligible? Well, we assigned E already, so F is eligible. G is not yet eligible, because for G to be eligible, we need to make sure that both E and F are assigned. So the task which is eligible is only F here. Okay, we are going to assign F, and F is going to take 1.2 minutes, and G needs 1 minute. We don't have any more time available to fit in G in this workstation, because time remaining is 0.8 minutes, right? So if you subtract 1.2 from 2, you have only 0.8 minutes left. So how much time is consumed by this workstation? Again, 1.2, same. Okay, you subtract 0.8 from 0.2 and you get 1.2 here. So we need the fourth workstation, because we still have G to be assigned. Okay, so again, every workstation will have 2 minutes to start with, because that's our calculated cycle time, and this calculated cycle time will vary depending on the problems. Okay, so it will not always be 2. Sometimes it could be 3, sometimes it could be in hours and things like that. In this case, it is 2. Okay, and the next eligible and the only remaining task is G, so I will assign G here. G takes 1 minute, right? So time remaining is 1 minute, because G is going to take 1 minute. 1 minus 2 is 1 minute. So idle time is 1 minute as well, and total time consumed is 1 minute as well. Okay, so they're all 1 here. Okay, something you have to keep in mind. So this is how you would assign the task. Okay, so we are done with the task assignment. Now we know that minimum number of workstations were 3, but actually we needed 4. Okay, so you see that it's always good to highlight different workstation with different colors, so you can identify them easily. Okay, so I'll just do the alternate highlighting. Let's say this one. Okay, so this makes identification of workstations easy. Okay, so actual number of workstation which is depicted by n actual is 4. We see it up there, right? That's where we see 1 2 3 4, and calculated workstations were 3. Okay, so we actually needed one more. Okay, and that's okay. So actual cycle time, we need to calculate the actual cycle time. So actual cycle time will be given by the maximum of this time consumed here. Okay, so what I'll do here, I'll say equals to max of all this time consumed, which is, we know, 1.2 minutes. So it's good to put in the formulas. So 1.2 minutes is the actual cycle time. Okay, so cycle time, in other words, is also the maximum time that you are going to spend at any workstation, because that workstation will determine the output rate as such. Okay, so that workstation is the bottleneck, because it's consuming most time, and that will establish the output rate of the line. Okay, so actual cycle time, we calculated it. Now what we have to do is we have to calculate the percent idle time and percent efficiency. So let's calculate the percent efficiency first, which is given by this formula: a total task time divided by n actual, which is 4, times actual cycle time, which is 1.2. So here again, what we have to do, we have to sum up the total task time. So let's sum it up. Okay, and then I would divide it by, let's say, 4 times 1.2, and then I guess the whole we have to multiply by 100, because we need that in percentage. Okay, so I will do that. Make sure you have to provide the opening parenthesis as well. So that gives me 95.83%. So line efficiency is 95.83%. So how would you calculate the idle time? Well, that is equal to 100 minus percent efficiency, So here 100 minus percent efficiency is 95. So the percent idle time for the line is 4.16%. So what is the takeaway from this problem here? Well, we assign the task to the line, which is the assembly line, in such a way that we can maximize the percent efficiency and minimize the percent idle time. And we followed a heuristic approach here. So this is just a heuristic. This is not the best of the best algorithm which will always produce good solution. No, there are thousands of algorithms out there, and actually the actual algorithm that's being used in the industry is going to be a lot more complicated than this one. But this shows you, how to use basic algorithm, and at least you get an idea how the task assignments are being done in the industry. Okay, so this is it here. Thank you very much for watching.